Hi there, this is BGK of Pear Tree Games. In this video, I just wanted to kind of go over and show you the world streaming package that I've been working with. Again, this is something that I've designed very much specifically for my game, and you'd need a lot of reworking for it to be applicable to yours, but I just wanted to go over the code and kind of the systems and how it works, and maybe you'll get some inspiration. So before we hop in all that, I figured I would show how it operates. We can see here that we are in world 00. There is an overworld, a bunch of other stuff for the main game, and then the neighboring ones. So we can see that we are in here. Then we have our neighboring scenes that are all loaded. Then our game here, we can kind of rotate. This is very trivial examples of the world, obviously, but just to demonstrate the purposes, we can see that I'm this little green dot here, and I'm moving east, as it were. And we're sitting here at about consistent 130 frames a second. Now we're in the next world, and we can see that they will unload and load in the new ones. So that is generally how the system works, the general outcome. It loads pretty smoothly, even in Editor. In Editor, there's a fair bit of extra overhead, but in builds, a lot of that overhead will be gone. So if it loads smoothly in the Editor, then again, these are trivial examples, so yes, they move smoothly. If you see hiccups and stuff in the Editor, then it still might most likely be okay in game because you'll be working with full builds, and you won't have any building processes happening on the fly. So we'll just do another one here and load up the next scene. So there we go. So that's it in action. I won't be going over the ocean because that's a whole different system, but if anybody wants to see how that ocean is built up, let me know, and I can probably go through that as well if you want, but it's a whole lot of other stuff. So the whole now, if you've been following along, I built a parent setter, which automatically, when you place any of these objects, it'll place them into their appropriate quadrants, as well as in their appropriate scenes. And then it'll do some optimizations by combining them with the colliders and meshes and such. And then what'll happen is the scene loader in the overworld will then have a target, which for us is this green dot here, or the player, or the camera, or whatever, and it follows it along, and then it'll load up all neighboring scenes based on a grid that were placed. And that's my cat in the background. So we can take a look at a bit of code here. Once you've got all of the worlds built up on a grid like this, loading them and figuring out which one's your neighbors is pretty trivial. So that's like the kind of the big part. Let me zoom in here, get rid of this. Okay. So the world streamer, the scene manager, target, like I said, a load delay, because you don't want to load as soon as you enter a scene because this one goes back and forth and back and forth. You don't want to be loading constantly, so you want to make sure you're loading after a bit of a delay. An event just that triggers once the world is completely ready, and then you can load in the rest of your objects, players, and whatever else you need. The current cell, the next cell, a list of loaded scenes, and a list of their kind of coroutines that you keep track of in case doubtfully that one is loading while you're trying to going to be unloading or loading that same one. So you just want to make sure you cancel that. and then a check because we want to spread them apart, a list of actions, and finally, these are just, again, things that I use to say that the world is ready to, so like the ocean, to make sure that the ocean is fully loaded. We won't call, yeah, while all those things aren't loaded, then we'll just wait. And then once everything's done, then we'll call that the world is ready. But the blocky scene actions here. So a list of actions that these actions are pretty much like a very, very crude priority queue where we'll put in the cell and an action will be either a load or unload of that scene, and then a priority. And then we'll simply sort them by highest priority, and we'll want to make sure that we're loading them first. So that's all that is there. So this would be most of the actually like interesting logic, I would say. But it's pretty simple. Based on our target position, we get our cell that we're in. And if we're in our current cell, then we just reset our load delay. Otherwise, if we're in our next cell, then we'll just subtract time. Really this, and if we're not in our next cell, then our target cell becomes our next cell. These kind of could be combined, but anyway. And then if our load delay is less than 0, we've set our current cell and we're just going to load that one. And this load scene will enqueue if it's not loaded, we'll enqueue the cell to be loaded, put it on the priority queue there, and then we'll also enqueue all the neighbors. And we'll get to those in just a second. So once we've called that, we then check the count. And if we're not loading, then we're going to grab the next one, set the cell of the loading and the coroutine, and call whatever action is on that one, and then start that coroutine, and finally remove that item from the list. So yeah, that's the most interesting part. This is just some preloading kind of initialization stuff, but I think this guy here, so where were we there? Yes, when we load a scene, we enqueue the scene to be loaded with the highest priority, which is 20 for this one. And then, so again, we'll check if the loading code, if it's not currently loading, you're not doing anything, or if it is currently doing something, I mean, we will stop it. We don't want to continue anything if we want to make sure that we're supposed to unload it. We'll then remove any action that contains that cell, because again, if it's already in the queue and it says to load it and then or unload it, we want to make sure that we're not going to unload it in that queue. We will then create a new action with the LoadSubScene action and add it to the queue. So the LoadSubScene, pretty simple. We set that we're loading, grab the scene name based on the cell, and if it's loaded, then we actually just go to complete here and just turn to false. We've already done this. However, if it's not loaded, first we check to see the resource location, and we want to make sure that that key actually exists, because not all your neighboring scenes will actually exist. So you want to make sure about that. If it is, again, just complete here. A lot of people have a problem with go-tos. I normally do too, but I just found writing is loading false yield break a bunch of times kind of weird, so just throw it to the end. Lastly, once we know that this resource exists, we can then load the scene in an additive mode. And again, if it's not valid, which it definitely should be since we've already confirmed it there, but this is just an extra check. And then we'll let that load, and we will add it to the loaded scenes. I added an extra wait here just for 0.2 seconds, just to space out the loading of the scenes, but not 100% necessary. And then finish it off. So that is when we are enqueuing a loading. And then we would enqueue all the neighbors. Now the neighbors is pretty much the same thing. We're just grabbing all the neighbors, except with a priority of 5. So we get the neighbors, loads and unloads, because whenever we transfer, we want to get all of the 2 loads and the 2 unloads, which would be the ones that are currently loaded, except with the ones that we want to load. So, if we go over to here, we want to load these ones and unload these ones. Pretty straightforward, I think. And then if we contain the current cell, we want to make sure we don't do that. And we return that. And then we enqueue all the loads and enqueue the unloads. Simple as that. And same thing with the unloads. We stop anyone that's currently coroutine that's running, remove any action that contains that cell, and then add the unload subscene onto the queue with the lowest priority of 0. Unload subscene simply grabs the scene from our loaded value dictionary and unloads it. Very, very easy. That's about it. So that's the whole system. There's a bunch of a lot of these utilities I actually went over in previous videos. There's a couple of new ones like get cell from scene name, does a bit of regex matching, get cell from world position, get neighboring cells based on a vector2 int and such. Not a whole lot there. And then lastly, there is some preprocessor. Actually, all this has already been covered. So that is about it. Yeah, so that's the system. I plan on kind of filling out the world a bunch more with actual kind of sketches that I've done. And so I'll be filling it out. Maybe I'll do a time lapse of that. I've also, in case you've been following along with the 3D tile map, I've made some extra, an ocean parent setter that allows me to place all the ocean tiles that you saw very quickly and allows me to keep them out of the scene, which is convenient. And then a one for my dissolving structures. So all these walls and stuff will automatically be placed where they need to be. And so yeah, that's some of the other stuff I've been working on. So if you have any questions, let me know in the comments. All the code is still up on GitHub for the world streamer. So if you want to take a look yourself, you're more than welcome to. Thank you so much. Thanks for watching. Have a good one.